Hey everyone, and welcome back to another part of our Mario Clone tutorial series. I am Chris, and we are going to now create some additional functionality to our player script. And the functionality that we're going to add is the player right now can only move to the right, can move to the left, and he can't jump. He has no gravity applied to him, so there is no change in his Y velocity ever right now. It's just continuously at where we put him, which is at 2.5. So his Y never changes, which makes for a very boring game because pretty much all we can do is we can go all the way to the left and we can go all the way to the pipe, and that's basically where we're going to be left at. So before we can implement jumping, we have to implement falling, which means we have to implement gravity. So, because if we were to just implement jumping right now, we would just be stuck in the air because we have nothing pulling us back down as far as gravity goes. So, unfortunately, we can't just implement jump and then implement gravity later. So we kind of have to implement all of it. So the first thing we're going to do is launch our player class. And in here, we're going to need a couple of more variables. One is we're going to need to be able to define a jump velocity for the player. So we're going to call this public float and name it jump velocity. Okay. And so this jump velocity is going to we're going to be able to set this value depending on how high we want the player to be able to jump. So that's something that we're going to actually set in the inspector in Unity until we can get the right kind of value that we want for our player. That'll be something that we'll have to play with until we get something that feels right. Okay. The other variable that we're going to need is, let's see, we're going to need gravity. And we want to manipulate gravity via the inspector as well. So that we can get a value there that feels good for the platformer that we're building. And so another, let's see here, we've got a layer mask that we've created as for the walls. So we're going to create another one for the floor mask. Okay. And with all of this going on, we actually want to be able to keep track of the state of our player. Okay. These right here, I called them states earlier, and they are. But what we actually want is we want to be able to keep track of what our current player or what our player's current state is. And the best way to do that is to actually create an enumerated variable. And what we do here is, the way we do that is we create a public, and let's call it player state. And we're going to assign, let's see, we want to know if the character is jumping, we want to know if he's idle, if he's walking, and let's keep it at that for now. We're going to come back and add something to the state enumeration later, but let's just keep it simple in jumping, idle, and walking. Okay. And then we have to, because this is now sort of like a type almost, it's an enumeration, we still have to create, this is not the variable, we have to create a variable, an instance of this enumeration. So we're going to create a player state variable, and initialize player state with, let's just initialize it with idle. We forgot to tell it the type that we're actually creating, so we're creating a player state type. Okay, now it's happy. Alright, so there are a couple more things. Keep saying there are a couple more variables, because there really are. We need to know, we need to keep track of if our player is actually on the ground. So we're just going to create a bool here and call it grounded. And initially we're going to set this to false. Okay. Even though it appears that our player is on the ground, we still want to set this to false to begin with. So now let's go ahead and make another method. This method, let's call it let's call it fall. Okay. And this method will pull the player to the ground from wherever he is at. Whatever position he's at, it's going to always pull him down. And the way that it's going to do that is it's going to set his velocity, his y velocity, equal to 0. And while we're in here, let's go ahead and change his state. And we're going to change it to player state dot jumping. And I'm going to explain why we're setting his state to jumping when we're falling in just a second. And finally, we're going to set grounded equal to false, because if he's falling, then he's not grounded for sure, because that's the point. I mean, he's falling because he's not grounded, so we're setting him to false to make sure. So the reason that we're changing velocity, his y velocity, to 0 is because in the next time that his velocity is updated, it's going to increment down to 0 depending on the gravity. The other part of this is that if he's jumping, he's basically falling. Everyone who jumps immediately is falling by the force of gravity. So as you're jumping up, you're constantly already being forced back down by gravity. And that's why we're using jumping, the jumping state, as basically jumping is falling, because we're jumping and falling at the same time. And that's how it's going to keep us down. And this is going to get more clear to you as we actually go into more of the code that makes this state happen. So right now we're just setting the state that we're jumping, but there's actually code involved with this, that actually deals with the whole player state jumping thing here that we created. So, and then finally we're just going to set his ground to false again. So what we're going to do is at the very start of our method, we're going to go ahead and call this fall method, even though he is on the ground. We just want to be sure that he's actually on the ground, just in case when we add the player he's just a little bit above the ground. We want to make sure that he's already going to fall. Okay, so we set his y velocity to 0, and then it's going to get updated, which we haven't written a code for yet, but we are going to. So in the same method that we created to update the player's position, to move left or right, we're going to create another if condition, and it's going to be outside of the walk condition, okay? Because here we want to test to see if jump, okay, if jump equals true, if the player is pressing the space bar, okay? And we also want to make sure that when the player presses the space bar and the jump is set to true, we want to make sure that his player state is not, sorry, and that his player state is not already equal to player state dot jumping, because we don't want to allow any double jumping here. We don't want to allow him to be able to press the spacebar after he's already pressed the spacebar, and that's what player state dot jumping basically does. Is it tells us that the player is in a jumping state, even though the jump is a state for the key. So the jump is a state for the key, and the player state jumping is a state for what the player is currently in. So if that is all true, right, the player state doesn't equal jumping and jump is true, then we immediately set the player state to player state jumping, because he's not, so he's going to. And we set our velocity equal to let's see, new vector 2, and we're going to pass it the current x velocity and the jump velocity. The x velocity because we want to continue sending the player in the direction that he's running in when he's jumping, so this is kind of like for air control. And the jump velocity because we want to, you know, our player to jump a certain degree, right? So to continue on, we check if the player state is equal to player state jumping. Okay, so now we're jumping. So what we want to do while we're jumping is we want to modify the reference position vector, the y value of that. We want to increment that by our y velocity, our current y velocity, and multiply that times time.delta time. Okay. And then what we want to do is we want to change our y velocity. We want to decrement that by gravity times time.delta time. Okay, so what this method is doing basically is we're taking our y velocity, our current y velocity, that was created when the player pressed the jump button. Okay, that jump velocity was stored in the velocity variable. Okay, along with the x velocity. Okay, so what happens here with this method is that what we're doing is we're grabbing our current y velocity, which was specified in here when the player initially pressed the jump button. Okay, we're multiplying that by time.delta time. Okay, and then we're increasing our position by that value, and then we're taking our gravity, multiplying that times time.delta time, which you'll remember is only a fraction of the actual second that we're in right now. It's you know, the number of seconds that have passed since the last frame, so it's a very, very, very small number. What we're doing, and then, you know, like I said, is we're multiplying gravity times time.delta time. We're subtracting that from our y velocity, okay, our current y velocity. And then on the very next frame, when this method runs again, this if statement will not execute because we're in the jumping state, okay? And since we're in the jumping state, it's going to take the y velocity that we calculated on our last frame, it's going to add that to our y position, again, multiplied times time.delta time, and then again it's going to subtract gravity multiplied times time.delta time. So what's going to happen is the velocity is going to continuously decrease from what we've initially supplied it. And our player first is going to go up in the y until he finally reaches a point where the velocity is actually a negative value. And once it becomes a negative value, the player is going to start coming down. And he's going to continue to go down past the ground, past everything else, because we haven't set up any collision detection yet. So we don't know if the player is grounded. We don't know what he's doing. So right now, we could we? We could jump. Yes, we could jump. Let's just go ahead and set that up in the inspector and see what that looks like. But yeah, the player's actually not going to fall, or will he? Yes, because we set the velocity y to 0, so the player should fall. But we're not calling fall, so we only call it in the start method. We don't call it again after that, so the player will not fall. The player will get stuck in the sky. So let's have a look at our inspector in Unity. And go to our player. Right now we're set at a 0 jump velocity. Let's go ahead and just give it a 5. And let's go ahead and set our floor mask too. Let's set that to set it to default. Like I said, all of our platforms are defaulted. Let's go ahead and assign gravity as well. Let's go with like 65. And okay, so let's go ahead and start the game. Oh, he fell to the floor because we're calling the fall method at the very beginning. So let's disable that for now. Okay. Right. So we're not going to fall. Not yet. First we're going to jump. Right. So press play. Okay, so here we are on the ground. We still move. Left. Right. Camera's coming. But now, if we jump, we fall. If we jump, we fall. Thought I disabled that. It's not going to matter. Because it's going to keep subtracting until it hits the ground. That's right. Yeah, so the reason that we fell, even though we're not calling fall only sets us to 0, so it brings us down. But what'll actually happen is when we jump, the velocity is just going to keep counting down because there's nothing to actually stop us. There's nothing to take us out of our jumping state. So we're constantly in this jumping state. So because we're constantly in that jumping state, this code right here is going to continuously run. Our velocity is going to continuously be subtracted by gravity, and our position is going to continuously be updated. So until we add in the collision detection for the ground, anytime we attempt to jump at this point is just going to send us plummeting to our endless death because we have nothing to stop us. So maybe we'll just not die anyways because we won't ever hit the ground. Because as far as we're concerned with reality in our physics world, we don't have a bottom collision. So as long as we just don't have that, we'll just keep falling. Okay, so to continue on, what we're going to need to do is we're going to have to do some raycasting towards the floor. So it's going to look very similar to our check wall rays, okay? So let's go ahead and get started with that. Let's create a, it's going to also return a vector 3 of the position, of the new calculated position if we collide with something. So we're going to call this check floor rays, okay? And we're going to pass in vector 3 position, and we're not going to pass in a direction because the player will always be oriented the same way when he's falling. First things first, we need to create origins for arrays, and then we need to create raycasts. So the origins that we're going to make for the bottom are not going to be top, middle, and bottom. They are going to be left, middle, and right because they're going to be casting down from the player on the left side, the right, the middle, and the right. So let's go ahead and create those. Those are just vector 2s, origin top, or sorry, origin left, new vector 2, and the position of the left one will be position dot x, and we're going to subtract 0.5f, and we're going to add 0.2f back. And the reason that we're doing this is we're subtracting 0.5f because it's half of the player, because our position.x is in the center, so we're subtracting half. We don't want the ray to be directly on the outside, so we're going to add back 0.2f. Okay, so that's part of the player, on the inside of the player. And then for y, we're just going to do position.y minus 1f because the player is 2 units tall, and the center of y, or the y position's in the center, so we're going to subtract 1 to get to the bottom of the player. Okay, and that is our left. So now we're going to do our right origin. Or sorry, let's go with the middle. New 2 position. Now here we're just going to do position.x, and then position.y minus 1f. Okay, and then for vector 2 origin right, I'm going to do new vector 2 position of x plus 0.5f minus 0.2f, and then position.y minus 1f. Okay, and here we're doing the same thing but opposite. of the left origin, we are taking the center of the player, we're adding half of the player, then we're subtracting 0.2 to create that origin just a little bit on the inside of the player. So now that we have that, we can create our raycasts, and those again are going to be very, very similar to the ones that we've done for the walls. So here we're going to do just raycast hit 2D, and this let's call this floor left, physics 2D raycast, and we're going to pass in origin left, and then we're going to pass in for the direction we're going to pass vector2.down, and for the length of the ray we're going to use our y velocity times time.delta time. And then for our mask, we'll use our floor mask that we've created. And let's create the next ray. Floor middle, physics 2D, raycast. Oops. Raycast. Origin middle, vector2.down. And velocity y times time delta time and floor mask. Just let me explain vector2.down really quick, just in case you're wondering. Vector2.down simply gives us a vector 2 that provides us with a coordinate of 0, -1, so meaning that 0 in the x direction and -1 in the y. Right. So we could have actually done new vector 2, 0, -1. That would have had the same result for our ray. Okay, so but we're just going to use this vector2.down property, and again velocity.y times time.delta time and floor mask. Okay, so those are our rays. So we've got our origins, we've got our rays, and then just like in the other function that we created, we're going to check each of our raycast hit objects for if they contain any collision or collider objects. So again, the way we do this is with an if statement. I'm going to do floor left dot collider doesn't equal null, or floor middle dot collider doesn't equal null, or floor right dot collider doesn't equal null. Okay. If any of these don't equal null, that means we have a collision. And if we do, we actually want to know what that collision is. Actually, you know what? We don't need to know that right yet. Right now, all we're concerned with is knowing whether or not we've collided with something below us. Because if we've collided with something below us, we want the player not to be able to pass through it. So we first are going to set our character state, player state equal to player state dot idle. Okay, this will take him out of that jumping state, so he's not going to continue to fall anymore. And then we're going to set our grounded Boolean variable to true, because now we know we're on the ground. We're going to set our y velocity to 0. And we are going to set our reference position vector, the y coordinate of that, to our, let's see here. Yeah, okay, so before we can set this, we actually need some hit information back from our hit object that our raycast returns. So the way we do this is we check which one of our raycasts actually return the information, right? So what we do is we do an if statement. If floor left, okay, it basically means that the floor left hit object has an object, has a hit object. If it does, then backwards. First, what we have to do is we have to create let's call it a reference variable to our hit object, and we're going to call it hit ray. And we're going to initialize it just with floor right. Doesn't matter. We do here then is we use this hit ray variable to set it equal to floor left. So if floor left has a hit object, then we want to set that hit object to our hit ray variable. So then, if it doesn't, though, then we want to check if floor middle has a hit object, and if it does, then we set our hit ray equal to floor middle. If that doesn't contain it, then we check floor right. And if that has it, then we set hit ray equal to floor right. And if that didn't have it, then we shouldn't be in this if condition to begin with, so it doesn't matter. So at this point, we have our hit information in the hit ray variable. Okay, so if any one of these return true or are not null, then we know we have a hit object, and we just need to find out which one it is. And if any one of these return true, it then sets hit ray equal to our hit object. So we can use hit ray to get some hit ray information, or to get some hit object information. And what we're going to do with this information is we're going to check our collider that we've collided with. We're going to check its bounds, okay, and we're going to check its position, and we're going to check its size, because what can happen if the player starts to fall down in a specific at a specific speed? The collider may collide with the platform or whatever the player lands on in a frame that the player may have shot just a little past that platform. So we don't want to ground our player at that point. We want to ground our player at the point where the platform is at its highest. So we need to find out what that point is. And in order to do that, we need to know where that collider is positioned, and we need to know what size the collider is, so that we can actually position our player correctly. So here's what we're going to do. We're going to set our Y position equal to hit ray dot collider dot bounds center dot Y. That's its location. We're going to add hit ray dot collider dot bounds dot size dot Y divided by 2, which gives us its size divided by 2 from the center, which is actually the top of it. And we're going to add 1 because that is half of our player's height. Because remember, our player's pivot point is in the center. So we actually need to add also half of the player's height, otherwise the player would be half into the platform. So that right there is going to create a new position vector for our method here when we're updating our transform.local position and our scale. So now all we need to do is we need to actually return our position vector. Okay, so now we just need to actually call this check floor arrays method, and the way we do this is we're going to do it in the update player position method. And we have to do this before transform.local position gets set with position, because position is what we're actually going to return. So, and we only want to check this. I mean, we could check it all the time, and it wouldn't matter. I mean, it's not really that heavy on CPU usage, but as good practice, and because we like to optimize code, we're only going to check this if our Y velocity is less than or equal to 0. So while the player is jumping up, we're not going to check while his y is greater than 0, we're not going to check to see if he's hitting a floor. So if the y velocity is less than or equal to 0, which means that he has fallen past the point of where the gravity actually allows him to travel upwards, we want to check the floor raise and assign the new calculated position to our position reference vector. So here we do position equals check floor raise, and we pass in position. And since it's only one line, and I don't know if I've talked about this, probably, but just to go over it again if I haven't or have, if we have an if statement that has only one line of code, we don't have to have opening and closing curly brackets, so it makes our code a little shorter, and it just looks a little neater too. So we're going to leave it this way. So here we go. In the update player position, we're checking to see if the y velocity is less than or equal to 0. If it is, we're going to assign the position that we get back from our check floor raise method. We're going to assign that to the position variable, and then here it gets assigned to the local position. So let's go ahead and test that out and see what we've got. We go to Unity and click play. Alright, so here we are walking, and we jump, and we come right back down. Because our jump force is so low, we're barely jumping, right? So we are exactly where we're supposed to be. Let's play with this value for a minute. We got 5 in the jump velocity. Let's go for 20. That looks a little better. Still can't get up past the question block. Let's try 25. Okay, that works really well, I think, but maybe a little too well. It jumps way too high, I think. Okay, so let's bring that down just a notch, or 223. Let's try that out. And this is the great thing about Unity, is you can edit these values while you're in the inspector. Oh, and remember, we're not calling fall, so when the player lands on ground, he's going to continue traveling on that ground until you jump again and there's nothing below you. So the first thing that you actually land on is what the player's Y is going to be for the rest of that time. So, yeah. And that's until we actually implement the calling of that fall method. So yeah, 23 looks pretty good to me as a jump height. We can maybe even make it a little lower. Still looks a little too easy, but we can play with that later. So the one thing is if you change these values during gameplay, what happens is when you stop gameplay, watch, it changed back to 25. So if you find a value you like, you should probably make sure you remember what you used and then change it while you're not in play mode. And then when you go back in, it's the right number still. So there we go. Jumping works. Gravity's pulling the player down. Notice how we can't hit anything with our head. And that's because we're not checking ceiling. Just something that we'll probably do next. But first, let's implement that the call to falling. So we're gonna stop it and let's see here. Okay, so the best place to actually add a call to the fall method would most likely be in the check floor raise method, because this method is checking to see if any of the rays are colliding with anything below the player. So we know that if none of these have a collider object, then we know that the rays aren't colliding with anything. So we can just add an else statement in here, and from here we can call our fall method. But instead of just calling our fall method, we have to check and make sure that the player's state doesn't already equal the player jumping state, because like I explained before, we're using the jumping state for falling and jumping, because when you're jumping, you're already falling, or based on gravity, because gravity's constantly pushing you down. So really, every jump is a fall. So then, if the character is not in a jumping state, then we want to fall, because we don't want to try to make or pull his velocity to 0 while he's in the middle of a jump, because that could actually break things pretty badly. So here, we're going to save it, and then go into Unity, and let's go ahead and click play. And now we can run, jump, and he falls. And now if we're on top of an object, if we walk off of it, he falls to the ground just like he should. Okay, no more random walking in the air. So that's all done. Now we can check the right bounds works too. It's good. Okay, so looks like our player is doing pretty much everything we want him to do right now. He's able to jump and fall and move left and right and stand on platforms. The one thing he's not doing yet is he can still jump through platforms, which is kind of like how one-way platforms work. One-way platforms, you would, for a split second, you would turn off the checking of the ceiling rays so that you could jump through a platform and get to the top. But we don't want to have one-way platforms, because the original Mario didn't have any one-way platforms. So we want to be able to strike these blocks and get coins out of them, which eventually we're going to get to. We're not going to get into breaking the bricks, but we also want to let's see here. We can't jump on the enemy because the jump is just too high. But here's yeah, that's the other thing we're going to have to implement, is we're going to have to implement code that checks to see if the players jumped on the enemy, if the players got hit by the enemy, if the player jumps to hit the coin block, if the player jumps to hit the brick block, if the player gets to the end of the game and jumps into the castle, or walks into the door. So yeah, there's still plenty of things to do here, but the very next thing that we're going to do is first we're going to stop it here, and so that I can give you guys a break. So what we're going to do next is we're actually going to get into checking the rays that go up, so that we can check to see if the players hit anything above him. So that'll be next, and until then, stay tuned, and I'll see you guys soon.